Howdy folks, just a quick one. We're going to take a look inside this switching power supply. It's an adjustable voltage and current power supply. The brand is Powertrain, but it's sold by Altronics. It's a 600 watt power supply, 0 to 30 volts and 0 to 20 amps rated. The part code is MP8310. I've had this supply for quite a while. I like it. It has plenty of power for most of my projects, and it doesn't tend to get hot. It doesn't have too many issues with like shutting off randomly or anything. It's a reliable power supply, and I like it. Let's take it apart. Folks, that wasn't too hard. We had, 8 screws to take off? I'm looking, and this case is actually pretty bent, so I wonder what's going on there. Okay, let's open her up. Beauty. Okay, so let's have a look at what we've got here. First of all, it's just a standard metal enclosure with a plastic front side. Don't forget, if you do this yourself, don't do it. There's high voltage inside, but also these little metal bits have to go in there before you put it back together. Taking a look at the internal construction, let's start at the AC input, which is this port here. Comes in through a filtering system, so inductor, capacitor, some it's class X or Y capacitors in there, just made to prevent some sort of interference. Through these wires here, which are insulated, that's good, I like to see that, into a big, big main power switch. Sorry, all these metal bits just came out again. Let's empty them out so we don't have to think about them. Cool. From there, goes into the board. We have an AC filter here, an inrush limiting NTC resistor, which is good. It prevents big surges of power from going through as the capacitors charge, and that prevents like the lights dimming and things like that. And it also prevents damage to the switch and to the capacitors themselves. Power goes through here and is stored up in these capacitors through a bridge rectifier, which just converts AC to DC. We have, this is going to be hard to show you guys. Let me see if I can get a light on. Okay, we got a better set of lights now. Man, the angle is still bad, guys. Come on. Okay, you'll have to take my word for it. You got 2 transistors down in there, and they will be high voltage transistors. They are designed to take the high voltage DC and chop it up back into AC, but at a much higher frequency, because these type of power supplies are called switching power supplies, meaning they take your AC input, convert it to DC, switch it through these transistors up to AC at a higher frequency so that they can use a more efficient transformer. Goes through the transformer, out through this hefty wire, and down into the rectifier stage. And what this is, it's a set of 2 diodes. Come on, can I get a picture of that? Nope, I cannot. Set of 2 diodes down in here, and they take the high frequency but lower voltage AC coming out of this transformer and turn it back into DC that the power supply outputs. Before it can do that though, or before you can output it, it has to go through a filtering stage. So you see these capacitors here, we've got a big inductor, and these smooth the output from the diodes to prevent any ripples going through to your project and destroying it. So these will prevent voltage spikes and any, just any irregularities that could damage sensitive electronics. Moving forward, we have, the lighting is so bad. We have a current shunt resistor. Is that better? Yeah, it is. Cool. We've got a current shunt resistor in there. It looks to just be copper wire. And the brains of the operation, which is on this little removable, oh, not removable, but it's a daughter board. It can read the voltage drop across this resistor for a set current, and it knows, okay, that's how much current we've got to output, and it will take that value from this knob here. So, something worth noting, the current adjustment is fairly coarse, so you only have one turn for the full 0 to 20 amps, but the voltage adjustment is on I think it's a 10 turn potentiometer, so you have a lot finer adjustment for the full 0 to 30 volt range, which is great. That means that you can have you have a better chance of being accurate with your voltage output. What else? So the screen, LCD display. That's pretty simple. It's got voltage, current, and it has a little light that comes on if you're drawing a lot of power for some reason. I don't know if it's a temperature thing, but it hasn't ever failed me. The fan does click on when it warms up enough, so that's something, I guess. It's there. I think that's pretty much it. The only ever thing that I've had with this power supply is this back capacitor here. So you see these long wires which go to the current output. Since they're carrying lots of current, when you're running the power supply at full power, you can get some voltage ripple or voltage drop across them. So what they've done is they've added a capacitor here as well as a resistor to prevent the ripples becoming too big. But I was doing some experiments with high voltage, so well, I was using a flyback driver to run a CRT TV flyback coil to draw big like arcs and things. I might post a picture of that or something, I don't know. Anyway, that draws really high current but in super short pulses, and so it melted the legs of this capacitor here. I've since replaced this one because the original one was just kind of sitting in the bottom here because it had literally just melted off, which is like, wow. Okay, so they definitely skimped out there, I think. They could have probably put a bigger capacitor with thicker legs at least and just a bigger capacity, but apart from that, I haven't had any issues with the supply. I don't really see anything where they could have done much better. I did have to calibrate this. See these little potentiometers here, the surface mounted components? You can adjust these with a screwdriver, and they are the precision adjustment, and that's to make sure that the voltage that you see on the display is actually what's coming out. So I had to do that when I got it because I found it wasn't like volts off, but it was like a tenth of a volt off or half a volt off or something like that. So it was significant enough that I decided to do that. Anyway guys, that was a quick teardown. There's not much else to mention. There is an auxiliary output, so 5 amps, and you won't draw more than 5 amps from this for long because there is a poly fuse, so an automatically resetting 5 amp fuse down in there. So if you try to draw more power than that, it will cut off. Yes, I lost the 2 screws. Don't get mad at me. They're on the floor somewhere. If I find them, I'll put them back in. Anyway, bless you guys. Take it easy. I'll see you guys in the next video.